other sort of as well. Okay, so welcome everybody. Thank you for being here, and thank you for the organizers for inviting us to the world's first prompt engineering conference. And my subject is democratizing AI with prompt engineering and experiences from the University of Oxford. And why do I say democratizing? Because this is what we see as the value of prompt engineering. And we are unique to have actually conducted such a course over the last few weeks. And I'm going to share you my experiences and the experiences of our students into building such a course and the experiences of what they have gained from this course. And I hope you will find a lot of value in this discussion. First of all, a little bit about me. This is my LinkedIn profile. Feel free to connect to me. My main sort of characteristic is that I'm a fellow at the University of Oxford on AI with a focus on engineering sciences, but also I have my own research company, so it's a kind of a hybrid of both academia and research for that. I also want to thank my colleagues Anjali Jain, Chris Norik, and Aisha Mutlu for the help in preparing the course, preparing this material and part of this course. And also, if you want to work with us and study with us, please feel free to have a look at our course links here, and we're very happy to work with you on that. So, I want to start off with a quote from Pablo Picasso. And Pablo Picasso said that computers are useless; they only give you answers. Correct? And that is relevant 50 years ago, as it is relevant today, as it is relevant in the future. So prompt engineering is interesting because it then engages the human to ask the right questions. If we take the idea of Pablo Picasso in the future. And this is going to continue. And this is what excites us about prompt engineering, because anybody can be can actually engage with more sophisticated AI work, as I'm going to show you in our course. And this is one of our students. So this is a doctor, a medical doctor, and he shared this after the course. And what he said is that essentially is that he tried to learn Python many times and didn't quite get there. But now with prompt engineering and with our course and with methodology, which I'm going to show you, he was able to skill himself to a data scientist level such that he was able to build applications on what was interesting for him. And this is what I mean by democratizing. This is the power of prompt engineering. It means that we can be inclusive. We can bring in people from all over the world into development, into data science. We can empower doctors. We can empower architects. We can empower movie makers to actually create AI or computing. So that's what I mean by democratizing. And this is some of the experience that I'm going to share with you, why we as Oxford are so excited about this idea and what is about rationale and the thought process for doing this. I'm very excited to share this with you, with any, especially if there are any educators. We are very happy to share with you how we approach this subject, because I think it's a great ecosystem for everybody to learn from each other. So whoever is in the audience, feel free to connect to me through the organizers or through LinkedIn. So we believe in this thing. We believe that AI will not take your job, but people who know AI will. And this is important because let's not look at the doom and gloom. Let's look at what is really possible with AI. And prompt engineering brings that right down to very basic levels. And this is really what excites us about that. And for the first time in the world, this is a conference on prompt engineering, but I believe we at Oxford are for the first time in the world, a mainstream institution like Oxford has created an AI course for non-developers. And we couldn't be able to do this before because historically you always needed to have a certain level of knowledge in Python before you attended an Oxford course, and this still continues. So we still have traditional courses which continue on very heavy Python work, which is a full stack AI course, and that's perfectly fine. But what is also interesting, what we thought about, is to empower people who are at the periphery of development. That means business analysts, account managers, technical architects, data analysts, project managers, IT sales and pre-sales people, even HR people. So these people have always wanted to be in development, wanted to be in data science, but they could not have the skills. And we thought that this is perhaps an opportunity for the human and the AI to work together through the knowledge of prompt engineering. And what can we do about it? So this is what really excited us, and we decided to take this step. When we decided to make this jump, we looked at some of the ideas, and these are the 7 reasons which we thought that prompt engineering is not a fad, and that we want to invest into it as a university, as Oxford. I'm very happy to share our insights and knowledge with other universities and other developers if you so wish. The first one is what I've already mentioned so far, is democratizing AI. That is a powerful idea for us, and we really believe in that. The second one is empowering developers. Now, developers all over the world are already empowered by all means, but we just believe that it's to a whole different level. And you can see that in various tools like GitHub Copilot, and the productivity jump you get as a developer. The third one is we are seeing prompt engineering and NLP interfaces into most products. So if you look at traditional products like Splunk or database interfaces or everything like that, everything is getting a prompt interface. And when you have that, then you are thinking that prompt engineering is a skill in itself. It's a skill which is sort of which is abstracting from any particular platform or product, and that makes it extremely powerful. The fourth one is easier technologies are adopted and morphed. By morphed, I mean they change. And I give you an example of SQL. So SQL has been around for a very long time, but SQL is very easy, SQL is very easy to do, and it still is around today. In the world of AI, it isn't going away, and I have seen it being adopted and used by different companies, different people, different platforms, primarily because it is such a low common denominator. And we see the same thing with prompt engineering. It's well worth investing into this technology, and we call it a technology. I'll sort of share you why it's a bit of an art and a bit of technology, but still, it still is a fundamental technology into this for the future. Then we thought about role of prompt engineering in the full stack. So this is a lot of work we are doing, especially at Oxford, working with companies like Microsoft and others. So we're looking at how we can take prompt engineering from everything across the agile stack, which means taking it from personas to test scripts, everything with that, and everything in the middle, correct? So what we are seeing today is development, prompt engineering for development and AI, but we see it extending in both directions, upstream to the personas and downstream to the tests with that. And this is where we see prompts as the glue which unifies the full stack. Then we see autonomous AI agents are the future. If you're not following autonomous AI agents, feel free absolutely to do so. I think that is where the future of AI and future of prompt engineering is going to be. And then we think that there are many things in AI which are very interesting. So for example, what happens when AI can reason? Yes. And we are getting into that discussion very slowly with some sort of prompts and some sort of things going on. But I urge you to think as prompts not only as the chat gpt interface, but to think about it as dealing with an entity who is going to get more and more powerful, correct? I'm not talking about some esoteric consciousness type of thing, but I'm trying to say that today you're dealing with something which is chat gpt predominantly, and it has a certain level of competency. And what I'm trying to sort of cast your mind in the future is to think about the idea that this entity you're going to deal with is going to be much more complex, much more richer, much more multilingual, and much more multimodal, and maybe capable of reason to a certain extent. And language to communicate with this entity is going to be prompt engineering. So this is how we see the world, and this is what made us commit to this course. And what we thought about was the philosophies based on how to use generative AI primarily for prompt engineering. And what we thought about was using low code and large language models. Now, we said that it assumes no knowledge of machine learning or coding, which means that it still means that upon completion of the course you should be able to build machine learning and generative using generative models. So that's a big ask, correct? So that's a big ask for somebody who may literally come from HR, or maybe a doctor, like I shared with you the example, has no knowledge of coding, and you are going to tell him that after the completion of this course, you're going to tell him or her that after completion of this course that they're able to be competent to a certain extent building either a machine learning application or a computer science application using prompt engineering and coding. And this is a powerful idea. It's also a bit risky to understand to make a commitment like this. So we were very confident, especially in our team, who with whose help we managed to build this. Um, so we chose four platforms. We chose ChatGPT, GitHub Copilot, Power Platform, and OpenAI Code Interpreter. And the glue with this was prompt engineering. And we said that we chose the platforms because we think low code is suitable for domain experts who do not code. It is suitable for developers who want to accelerate coding, and it is suitable for automation of processes. So with that idea, we chose these four platforms, and they range in skill. So there is the GitHub Copilot, which is a strong developer focused platform. And then there is ChatGPT, which is the lowest common denominator across things, and so on. So that's how we decided to choose four platforms with these three goals. And then, of course, you have the Power Platform. The Power Platform is amazing because we then were able to build whole systems using AI with that. Now, one important point I wanted to state with you is the word low code is different today than it was 1 year ago. If you looked at 1 year ago, which is effectively pre generative AI, you are looking at low code, meaning effectively graphical user interfaces and configurations and so on and so forth. Um, but today, and of course you are doing a drag and drop. Today it is a little bit different, so it actually has that plus a few more things. The two most important things are code generation ability, which means assisting, automating the prompting, code snippets, structures, and including the entire applications. And the second one is automation. These is extremely powerful areas of prompt engineering, which we thought were so exciting that we are committed to this concept. And I can tell you that this course was fully oversubscribed, and I still get people looking at it. And of course, we have other courses which we have launched now, and they are also going to include prompt engineering in quite a big way because we like the experience which we have gained by early adopters by adopting this strategy with that. So, and I already talked to you about the prompt in the prompt Power Platform, which we also built it with the end to end. So in the end, what was happening was people were able to look at multiple platforms, choose what they wanted with the glue of having prompt engineering across these platforms. Now, what is a practical way to apply prompt engineering for design patterns for data science? Now, I shared with you that this is an AI course, correct? So we are primarily an AI organization within Oxford, and I certainly all my courses, including cybersecurity, digital twins, they all are basically AI courses. Now, we thought about what is a common paradigm which brings this together, and this was design patterns. So we thought that design pattern is a template or a description to solve a particular problem and used in different scenarios, it's a different situations. So we thought, how could we create design patterns using prompt engineering for the purpose of data science? Now, of course, there are many examples already of using prompt engineering with data science and prompt engineering with other things, and we use that, meaning that we picked up some of that and we adapted it to our application, which I'm going to share with you with that. So we thought about three basic steps, and what was underlying was a problem that applying prompt engineering patterns in isolation is hard. Rather, we thought about prompt engineering as a solution to problems in steps, where the smallest building block is a prompt. So we decided that look at the problem types. In our case, in data science, there are typically four problem types, which are the simplest levels. They are the regression, classification, clustering, and MLP. Now, these are not simple. What I mean, these are most common. correct? Then the second one was we thought about creating patterns for each stage of the flow. So look at data cleaning, look at each of the stages. We thought about creating patterns. And third, and the most important, we thought about designing mitigation patterns for by problem statement. Now I'll explain to you what mitigation patterns is. So this is how it looks like. So if you have some familiarity with data science, then this is the overall flow of data science. You generate data set, you suggest data set, you do data exploration, you build a model, you train a model, and so on. And we broke that down into a series of sub steps with that. And for each of those sub steps, we have one or more prompts, which is what I'm going to share with you more or less. And then there are other steps, of course. So there's hyperparameter tuning, addressing imbalance of data. Then there is clustering, dimensionality reduction. And then there are some more things, explainable AI, and so on. And then we thought about also using conceptual knowledge-based things, so data exploration, data visualization, and data machine and machine learning. So we realize that there are people who are working with us who actually do not know some of the terms used in machine learning. So our idea was, why don't we just teach them using prompt engineering, correct? Rather than us having create one more lecture, one more thing, one more session, why don't they just teach them how to fish, so to speak? So that was our philosophy in which we brought this thing together, and this is how we did it. And how we did do it, so this is examples of this, and this goes on for a bit of time. But what we thought about, this is how you generate data. So these are the prompts, and typically we ask you to ask the GPT to act as something, and then we give it lot of detail. Now the important thing is actually the detail. So for example, these were all created by my colleague Aisha and Anjali. And what we try to do here is that we say that I want you to act as a data simulation expert and generate a data set that simulates a certain process with certain parameters. And we keep on throwing this at the prompt engineering idea where we build certain things. Now everybody knows that obviously everything you build from prompt engineering, you can't actually use it as it is, and this is perfectly fine. So we are using it as a tool to generate something, and this is where the mitigation patterns come into play. Then suggesting data set, the same idea. We think about you as a data science career coach, and we want a productive model for something. So this is always a strategy. We always ask it to act as something, and then we ask it to give something, and then we put as much detail as possible into our prompts, and the prompts are detailed with that. And this goes on and on. So even when we talk about data merging, data reshaping, summary statistics, so it's not like we just don't say that, okay, give me a summary statistics or something. We are always building some level of detail with that, and including data pre-processing. This is the classic sort of finding missing values, finding duplicate records, and so on. So we keep on providing all this sort of a context and knowledge, partly which we have built up from searching on other prompts in the web, and also partly we have built up based on our own knowledge. So, but the significant thing is we put all that in a workflow, because what happens with the student then is the student is given a problem. I'll explain this to you further, and then they are given all this effectively these patterns, and then the student works with the problem, with the pattern, with the data set, and then off they go trying to build something. And in this case, they are achieving a lot just by doing prompting, because then that gets us maybe about 60-70% of the way, and then they have to work further from there. But this is the beauty of what we are trying to do. Then this goes on to data wrangling, data visualization, feature engineering. This is obviously, for a data scientist, you know that these sort of things take a lot of time to do. And then we of course build the model. So we talk about how to build a model using the code. Obviously, to run the code, you need an IDE, correct? So it depends on which platform you are working with. For example, if you're working with a Copilot, then you have to set up your IDE using Anaconda or something like this. If you're working with just straightforward ChatGPT, then you have to generate the code and copy the code into something else like a Colab notebook, or anything else, and or any other IDE, Visual Studio Code, and then run it like that. So this is still a little bit of a step from just running some prompting and running an output. But what we believe is that it takes people a hell of a lot forward what they would do if they didn't have these tools. And the significant thing is it's across all the steps. You can see this, correct, including things like hyperparameter tuning, data imbalance, clustering, dimensionality reduction, and so on and so forth. So this is basically where it goes on and on with that. So um, then, assuming you have generated the code, what is the next important step? The next important step, and the very important step, is mitigation strategies. Now, mitigation strategies is we actually encourage students to spend a lot of time in mitigation strategies. And why do we do that? Think of what Pablo Picasso said, correct? So don't trust what is out there, what it has been produced, but rather trust yourself. So we teach students to understand what is wrong. So understand what is erroneous coding, how to improve your code, how to write maintainable code, how to write security, how to write functional code, how to prevent hallucinations. And then we also look at a whole bunch of traditional sort of design patterns, and that includes chain of thought, least to most, etc., etc. Yes. So given a problem, this is a regression prompt from Anjali Jain, who is my colleague at Oxford. And what we did, this is the sort of prompt we start with regression, correct? And this goes on to 3 pages here. This is our prompt, and it goes on here, so it ends here. Yeah. But the significant thing about it is that it is very detailed. It's not just your usual sort of give me something on regression, but it also ends very cleverly. It ends in a way which says that after each step, give me the code, explain the concepts used in the code, make compatible with Jupyter Notebook code, and make sure that it should work with the previous step. So this is very interesting. It's amazing what prompt engineering gives you if you are if you ask the right questions, and if you are detailed with your questions. And that's the level of detail we go to. And again, I appreciate that not everybody is a data scientist here on this course, but I guess most people would be able to understand what I'm trying to say here is the idea that that it is about the level of knowledge you have about the subject. So, for example, if I were to try this for the legal profession, I would fail hopelessly. I have no clue about legal things, correct? But this stuff we know how it works, so we know how to design the prompt so that it makes it useful. And then we thought about, there's a whole large number of prompt engineering techniques, and to be honest, it does sort of overwhelm you. We follow research papers, and every 2 days something so spectacular happens. Yes, everybody said that this is the new way to go, and this is the new technique. And if you look at a particular paper, it's essentially a prompting technique, and it's chain of thought prompting, least to more, self-consistency decoding, and there's a whole list of them. And we thought, okay, this is great. We will include them. We will show how they work. But our goal is to solve our problem. Our problem as a data scientist is very specific. We then look at the data science workflow and break that into prompts, into design patterns. And then we see how that fits in. And then we see how mitigation patterns are on top of that. And then we provide these wider set of prompts as a series of cross references. So this is then creates a repository or a knowledge base for our students to take them, accelerate them to a very significant level, even if they are not developers. And this is what I see as the power of prompt engineering. And this just goes on, correct? So all these other things which go along as well. Just to recap, this is the set of sequences for this. These are the same steps which are in machine learning. And these are some of these ideas from these are some of the references I took on the web. But I come back to our student, correct? I come back to the power of prompt engineering, which was shared by a comment from our student. And what he said essentially the same. This is the medical doctor from Cambridge, and he basically said that I couldn't have done this without this sort of ability. And it is truly empowering as educators. It's amazing to see this as to what is education, correct? In the end of the day, education is that you start at a particular point and you end at a particular point after the course, and you should be empowered to do something. You should be able to take that knowledge and apply it into your knowledge, your domain. And we see this today. And I have got other examples I'm happy to share with you. I mean, this one was just because it was on LinkedIn, and it was so appropriate at that time. Again, come back also with Pablo Picasso. So think about yourself, think about your own abilities, think about the potential of what you could do by engaging with AI through prompt engineering. And as usual, feel free to stay in touch with us. Thank you also for my colleagues. Thank you for the organizers, Maxime, and all the team for inviting me. And yes, very happy to stay for questions here as well.